Today I'd like to talk to you about Blend Mode. Blend Mode is a new visual effect available in Camtasia 2022. It allows you to combine an image or video with the images or videos below it. There are 31 separate algorithms or blend modes that you can use to blend layers together, and with those you can create some really useful and aesthetically pleasing effects. In this video, we'll do a quick rundown of what each of those blend modes does. The first thing we need to do is discuss some basics about digital images. Every digital image is comprised of pixels. For example, a 1080p video is 1,920 pixels wide and 1,080 pixels tall. That means that every 1080p image contains exactly 2,073,600 pixels. Every one of those pixels has a color, and that color is represented by three values: red, green, and blue. Each of those three colors has a value between 0 and 255. The reason this is important is that blend modes work directly with those color values. Each blend mode represents a simple mathematical operation between the colors of the top media, which we'll call the blend layer, and the colors of everything beneath it, which we'll call the base layer. To apply a blend mode, first place one visual media on a track above another visual media. These can be images or videos. Then, click on Visual Effects and drag the blend mode effect to the upper media. This turns the upper media into what we call a blend layer. The default blend mode is Screen, which makes it easy to understand that this effect combines two media together. Now, let's go through the blend modes one by one, discussing how each one works, and let's explain ways in which they can be used. The first blend mode is called Normal. Its mathematical operation is that it uses all of the colors from the blend layer and none of the colors from the base layer. This is the same thing as just placing one media on top of another. It is primarily useful if you are working with other blend modes and temporarily want to work with the blend layer without seeing it interacting with the other layers. The next blend mode is called Dissolve. It is almost exactly the same as Normal with one key difference. If you adjust the opacity of the blend layer and the blend mode is normal, then the blend layer becomes transparent. If you adjust the opacity of the blend layer and the blend mode is Dissolve, then the blend layer randomly chooses pixels between the blend layer and the base layer, with more pixels from the base layer chosen as the opacity goes down. This is not very useful on its own, but when combined with a blur callout, it can create a nice texture that can be useful for things like graffiti effects. When you look at the list of blend modes, you will see dividers separating the blend modes into categories. Normal and Dissolve are in the normal category, since neither of them really blends the colors of the two layers. The second category is called the Darken blend modes, and those work by darkening the base layer using the color information from the blend layer. To help explore how that works, I've created two specialized assets that will help illustrate what's happening. The first is a set of vertical color bars. Note that in addition to a set of colors, it also has a white bar, a gray bar, and a black bar. The second is a set of horizontal bars that start with white at the top and then get progressively darker as it approaches the bottom. The first of the Darken blend modes is called Darken. Darken works by comparing each color channel, red, green, and blue, of each pixel in the blend layer with each channel of each pixel in the base layer. If the color value is lower in the blend layer, the result uses the value from the blend layer. If the color value is lower in the base layer, it uses the value from the base layer. Here I've used the Darken blend mode with my color bars as my base layer and my gray bars as my blend layer. As you can see, each color gets progressively darker as it blends with darker and darker grays. Two other interesting results are shown here. The first is that orange turns dark yellow as it gets darker. This is because orange is more red than it is green, and yellow is equally red and green. Thus, as each color channel gets darker, they become more equal and thus more yellow. The other is that the gray bar is unchanged for the first three bars. This shows us that the base layer wins until the color channels in the blend layer are darker than the base layer. Another way to illustrate this behavior is to put a color adjustment effect on a video and place the gray bars on top of it as a darkened blend layer. Then, if I change the brightness of the video, you can visually see when the blend layer wins versus when the base layer wins by getting darker. The next Darken blend mode is Multiply. Rather than just comparing color values between the blend layer and the base layer, Multiply treats each color channel in the blend layer as a value between 0 and 1. That value is multiplied against the corresponding color value in the base layer. Here I've used the Multiply blend mode, once again with my color bars as my base layer and my gray bars as my blend layer. As you can see, this creates a smoother, darkening result. The nonlinearities that we saw in the orange and gray bars are not present when we use the Multiply blend mode. An interesting ramification of the multiply algorithm is that you can use the same video as both the base layer and the blend layer. When you multiply a video against itself, the result is a darker video that retains a richer color palette than you'd get by merely reducing the brightness. Here's our video of two actors. It is being used as both the blend layer and the base layer. If we turn the blend mode effect off and on, we can see a rather striking difference. The next darken blend mode is color burn. When you apply a color burn, dark pixels in the blend layer increase the contrast in the base layer. That is to say, if a color channel is medium dark in the base layer, a dark pixel in the blend layer will make it very dark. This is kind of hard to see in the color bar example. The only real hint we get is that the orange bar turns red as it gets darker. This is because the dark pixels in the blend layer push the green color channel down, and as you subtract green from orange, it becomes red. Color burn is very powerful in two ways. The first is when blending a video with itself. The result is a high contrast video where bright colors stay bright but mid-tone colors are significantly darkened. The second technique is to place a solid rectangle callout on top of your video. Apply the color burn blend mode, and then use the color picker to affect the color of your video. This technique yields interesting results with all blend modes, but color burn is particularly effective at creating results that are subtle and useful. The next darken blend mode is called linear burn. This is similar to color burn in that it uses dark pixels in the blend layer to increase the contrast in the base layer. However, unlike color burn, linear burn is less protective of bright colors and creates a more natural darkening effect. Linear burn can accomplish another interesting effect as follows. Place a video above itself, then place a blur callout on top of the upper video. Group the blur callout with the upper video, and then apply a linear burn blend mode to the group. This creates a very pronounced soft focus effect, which can then be scaled back using the intensity slider. The last darken blend mode is called darker color. Unlike the other darken blend modes, darker color doesn't use individual color channels to do its work. Instead, it compares the overall brightness of each pixel, and if the blend layer is darker, it takes the pixel from the blend layer, and if the base layer is darker, it takes the pixel from the base layer. Here we have the result of blending the gray bars with the color bars using darker color. As you can see, red is darker than orange, so it wins against more gray bars than orange does. Yellow is the brightest color and wins least, whereas blue is much darker and beats every gray color until black finally wins. Darken color doesn't help much in terms of color grading, but it does have a weird capability. If you have an image where the foreground is darker than the background, it is possible to place things behind the foreground in an existing image. Here I have a city skyline with white clouds behind it. Because the buildings are darker than the clouds, I can exploit this property by placing a text callout that is darker than the clouds but less dark than the buildings. This creates an illusion suggesting that the text was behind the buildings in the video. The next category are the lighten blend modes. Each of these is simply the inverse of a corresponding darken blend mode. Where darken blend modes use dark pixels in the blend layer to darken the base layer, lighten blend modes use bright pixels in the blend layer to lighten the base layer. The first lighten blend mode is called lighten. It is the inverse of darken. If we look at the gray bars blended with the color bars, we see the exact opposite of what we saw using darken. Most of the colors get lighter as the gray bars in the blend layer get lighter, but there are two interesting discontinuities. The first is that orange turns into pink as it gets lighter. Recall that using darken, orange became yellow as it got darker. This is because instead of green being darkened out of the color, red remains constant while green and blue become equal, which has the effect of red mixing with white. The gray column is also the inverse of what we saw using darken. The original gray from the base layer wins for the darkest 3 bars, but the blend layer wins for the uppermost 3 bars because they are lighter. Using the same experiment we used with darken, we can see that if we use color adjustment to alter the base layer, a similar effect happens but in reverse. As the base layer gets lighter, it wins against more gray bars in the blend layer. The next lighten blend mode is screen, which gets its name because it looks like the blend layer and base layer are projected together onto the same screen. Screen is the default blend mode, and it's the inverse of the multiply blend mode. Just as multiply makes a bright video darker by using dark colors in the blend layer to push colors in the base layer closer to black, screen makes a dark video brighter by using bright colors in the blend layer to push colors in the base layer closer to white. Recall how we were able to multiply a bright image with itself to darken it. In the same way, we can screen a dark image against itself to lighten it. And, as the name implies, we can also use screen to combine 2 images together in such a way that we can see some parts of both. Next we have color dodge, which is the inverse of color burn. Color dodge lightens the base layer by using the colors in the blend layer to increase the contrast. In the same way that color dodge is the inverse of color burn, its usage is also its inverse. Recall that color burn is very useful for tinting an entire image in a subtle and helpful way, and that the sweet spot to use it in that way is to set your color picker near the upper left and then adjust using the hue selector. Similarly, if you apply color dodge and select near the bottom right of the color picker, you can use the hue selector to tint just the highlights of the image. Take the example of this dark blue image of a shipwreck. By using color dodge and playing with the color picker, I am able to bring out the reds and oranges in the sunset that were barely visible without it. Note that it is possible and useful to combine color grading effects. Here I have an untreated video of another shipwreck. Using color dodge with a red rectangle, I can add some warmth to the light colors, and then by using color burn with a blue rectangle, I can deepen the blue of the water. The next Lighten blend mode is linear dodge, the inverse of linear burn. Whereas duplicating a video and applying linear burn creates a deep darkening effect, linear dodge creates a very powerful lightening effect, so much so that you will probably want to reduce its intensity. One fun application of linear dodge works as follows. Duplicate a video and apply linear dodge, then put a shape on top of that and a blur on top of the shape. Group the blur and the shape together and apply the media matte effect to the group. This creates a custom spotlight effect. The last Lighten blend mode is lighter color. As you probably guessed, it's the inverse of darker color. Lighter color compares the brightness of each pixel and takes the blend layer if the blend layer is brighter or the base layer if the base layer is brighter. Employing lighter color, we can use the same technique we use with darker color, but on a base layer that has a dark background and a light foreground. Here, I've applied lighter color to my purple text and my blue micro animation. The purple text appears to be behind the white graphic in 3D space and in front of the background, despite it being drawn on top of an existing video. Blue is darker than purple, so the blue micro animation appears to be behind the text, despite it being drawn on top of both the text and the video. The next blend mode category is called the contrast modes. The easiest way to think of these modes is this. The darken blend modes do nothing if the color is white, and the lighten blend modes do nothing if the color is black. Contrast blend modes do nothing if the color is a medium gray. If the color is darker than medium gray, a darkening blend mode is applied. If the color is lighter than medium gray, a lightening blend mode is applied. In this way, contrast modes combine complementary darken and lighten blend modes together. The first contrast blend mode is overlay. Overlay applies screen to light pixels and multiply to dark pixels. If we combine our color bars together, we can see that white turns orange to yellow and black turns orange to red. However, looking at the color bars, we notice something else. The gray bars don't turn all the way black, and the color bars don't turn all the way black or white, even though that's what multiply and screen do, respectively. This is because overlay uses the brightness of the base layer instead of the blend layer, and the colors of the two layers are mixed together. This has the effect of being fairly protective of the base layer. Overlay is very useful in at least 4 different ways. The first is that when used on a video duplicating itself, it creates a sharpening effect that brings out details. The second is that because it has a softened tinting effect, it allows for a lot of precision while color grading. The sweet spot is right here in the middle of the color picker, and you have a lot of room to play. The third is that it's a very useful blend mode when using a gradient. Here I have a circular gradient that is dark in the middle and white at the outer edges. If I apply the overlay blend mode, I can move that gradient around to choose which part of my image will contain the most detail and contrast. And the fourth is that, when applying FX overlays like film grains, overlay is often the first blend mode to try because it does a good job of showing the blend layer while also preserving the base layer. The second contrast mode is soft light. It works just the same as overlay, except the mix is weighted more toward the base layer. Use soft light for the same purposes as overlay when you're looking for subtler results. The third contrast mode is hard light. Hard light works the same as overlay, with one key difference. Overlay uses the brightness of the base layer, and hard light uses the brightness of the blend layer. This means that when using a colored rectangle to color grade your video, overlay will apply the color grade selectively based on the color of the base layer. Hard light will apply the color consistently because every pixel in the blend layer has the same color and brightness. The difference between overlay and hard light is easiest to illustrate by clicking the invert box, since overlay and hard light are the same effect, inverted. Hard light effects are very unsubtle, so you may find the intensity slider to be helpful when using the hard light blend mode. The fourth contrast mode is vivid light. Vivid light applies a color burn for dark pixels and a color dodge for light pixels. It's a very powerful effect, so much so that you will almost always want to back it off a bit. Here's one helpful usage of vivid light. You can use it to bring out a color that you'd like to emphasize. Here I have an untreated stock video of an actor. I cover it up with a rectangle, I applied the vivid light blend mode, and then I changed the rectangle's opacity to 0. Then I used the color picker to pick out a color I'd like to emphasize, in this case the color of her eyes. Then I can use the opacity slider to choose the amount I want to emphasize that color in the result. The fifth contrast mode is linear light. It combines linear burn and linear dodge. Its effect works like vivid light, with the difference that whites and blacks are not protected. This results in a lower contrast image which looks more natural. That may or may not be what you want. When using linear light to emphasize colors, try hitting the invert box to see what it does. In some cases, you may decide it's an improvement. The sixth contrast mode is pin light. Pin light combines darken and lighten. As you might remember, darken and lighten have these interesting discontinuities which create a kind of color shelf that opens up a couple of possibilities. If we switch our actor from linear light to pin light, it gets lighter overall, but one subtler change is that more of the image is the same color. If we turn down the opacity, we can see the original image. If we turn it up, it's like we're retouching out the details of the actor's skin. If we put a fully opaque rectangle on top of these actors and mess with the color picker, you can see that there's a complex interaction between the blend color and the base layer. Pin light pushes the entire result in the direction of being monochromatic, but it does it in this interesting, discontinuous way. If we select carefully, we can place our actors in front of a single color. Then we can apply color adjustment to the actors to increase their contrast with the background. The last contrast mode is called Hard Mix. Hard Mix is totally unlike any other blend mode. It works by adding each color channel from the blend layer with each channel in the base layer. If the result is a number over 255, the result keeps that color at its max value. If it's 255 or below, that color reverts to 0. Every color goes big, or it goes home. Hard Mix has the effect of separating the image into up to 6 discrete colors, plus black and white. On its own, that might not seem very useful, although it can make for cool poster effects. However, it becomes very useful because that segmented video can be used as an input to other blend modes and other visual effects. Remember that you can add as many blending layers as you want. We'll see a couple of examples in a few minutes, but the possibilities are literally endless. The next category is called the Inversion blend modes. Inversion blend modes work by doing a mathematical operation between the blend layer and the base layer instead of blending them together. The first inversion mode is difference. Difference compares each color in the two layers and subtracts the smaller one from the larger one. Black does nothing, while white inverts the color completely. Difference is useful in at least two ways. The first is that you can use it to push the color in an image very hard in the opposite direction. Here I have a city skyline with a rectangle on top of it using the difference blend mode. I select a blue hue, and then if I push up from the bottom right of the color picker, I push the entire image hard in the direction of yellow. I can animate this change, and it seems like a sunset. As you can see, a little difference makes a big difference. The second way you can use difference is this. Here is our video of two actors. In the past 18 or so minutes, you have seen this video maybe 4 dozen times. This time, I changed it a little bit. Can you see it? I'll give you a hint. I added a pixelate callout. See it now? It's very subtle. We can use the difference mode to find it. I add the same video on top of the one I changed, and then I apply the difference blend mode to that. You can maybe see that there's a blotchy area up here. Let's make that easier to see. I'll add a white rectangle on top of that, and now I apply a hard mix to that rectangle. Now we can see the difference clear as day. The second inversion blend mode is called exclusion. Exclusion works like difference, except midtones get left alone. This leads to a grayish section, where all midtones seem to be preserved with the gray overlay. Exclusion is a little tricky to use, but when used on a gradient, it can have a pleasing effect. Here I've got my blue shipwreck and a gradient circle with black in the middle and white at the outside. If I apply the exclusion blend mode, you can see that the original color is preserved in the black part of the gradient, and where the gradient was white, the colors are inverted, with a smooth transitional zone between them. You can give this technique a little help by applying a color tint effect to the gradient. The third inversion blend mode is subtract. Subtract simply subtracts the colors of the blend layer from the base layer. Put another way, it applies a photo negative of the blend layer to the base layer. Subtract works very well when paired with a gradient. The effect is similar to a media matte, but is more pronounced. If you apply color tint to the gradient, between the colors in the tint properties and the two intensity sliders, you have a lot of control over the behavior of the gradient. The last inversion blend mode is divide. Divide takes the result of dividing the blend color by the base color and divides white by that result. That sounds complicated, and the color bars don't help very much in helping us understand how it works. It's easier to see what's going on by using a gradient. As you can see here, as the blend color gets darker, it pushes the colors in the base layer very hard toward white. You can use Divide as a powerful lightener, but you can also use it for a very specialized purpose, removing tint from a video. It works like this. Here I have a video of a person who is wearing a shirt with blue and white stripes. The video itself has a little bit of a blue tint to it, and that's what we want to fix. I cover the person halfway with a white rectangle, and then I use my color picker to change the white rectangle to what white looks like in the video. Then I apply a Divide blend mode. This has the result of turning the white in the video into actual white, and as a side effect, it removes the tint from the rest of the video as well. Let's try the same experiment with this person. The next 4 blend modes are called the component blend modes. For these, we stop thinking of colors as being comprised of 3 color channels, and instead consider a color as comprised of 3 components: luminosity, which is another name for brightness, saturation, and hue. When we use Camtasia's color picker, we are already working with these components. Up and down inside this box changes the luminosity, left and right changes the saturation, and this slider on the right selects the hue. Component blend modes let you enforce a component from the blend layer onto the base layer. That is, if you select the hue mode, then the hue in the blend layer will dictate the hue of the base layer, but the base layer's saturation and brightness will remain the same. You can do this with hue, saturation, luminosity, and color, which uses both the hue and saturation from the blend layer but not the brightness. The easiest way to illustrate how this works is this. I'll duplicate this video of a lighthouse, and then I'm going to crop the duplicate so that it's only covering the right half of the original. Now I'm going to apply the luminosity blend mode to the duplicate. The duplicate is now a blend layer, and the luminosity of the blend layer is controlling the luminosity of the base layer. Now I add the color tint effect to the base layer. We immediately see that the base layer, which is unaffected by the blend mode on the left, loses luminosity when the color tint is applied. On the right, the blend layer stops that from happening. The color change takes place, but the luminosity is held constant. Now we can try this in the other direction. We'll switch our blend layer's mode to color. Let's turn off color tint and add color adjustment. Now if we turn the brightness to normal and crank the saturation and contrast, we can see that the blend layer, which is covering the right side of the image, is holding the color constant while the base layer changes. If we move the saturation down to 0, the base layer turns black and white, but again, the blend layer is enforcing that the color remains the same. A fun thing to try. Let's duplicate this video and then do a hard mix on the top video with a gray rectangle. Let's say we like the way this segments the image, but we don't like how it changes the color. We group the rectangle and the first video together, and then we add a luminosity blend mode to that group. This means that the video with the hard mix is in control of the luminosity, but the base layer is in control of the color. This gives us the segmentation of the hard mix without losing the original color. The last 4 blend modes are the matte modes. If you're familiar with the media matte effect in Camtasia, these work just like those, with one important difference. Media mattes only affect the layer beneath the media, whereas blend modes treat everything underneath the media as the base layer. This means that media with a matte blend mode will cut all the way to the canvas, unlike a media matte, which will only cut through one thing at a time. I hope you enjoyed this video and learned a thing or two about blend modes. In a future video, we'll discuss more advanced blending techniques using blend ranges. In the meantime, thanks for watching and happy blending!